Okay. Assalamu alaikum and hello. Uh, Welcome. Grade 8. Welcome back to grade 8 mathematics with Inspire Teens. Please, before we start, can you guys please confirm that you guys can hear me loud and clear and that you can see my screen? Okay. Okay, as well as YouTube, can you please confirm that you guys can hear me? Perfect, perfect, perfect. Thank you guys. Okay, cool. I think we can get started, eh? Perfect. So we're going to continue where we left off last week, and that was with long division. Okay. I said that we'll go through some short division as well. Okay, no, sorry, just give me 1 second. Okay. So I said we'll go through the method of short division as well. So that's what we'll do, right? So remember long division, right? We had this first example where we said 4, 4, 6, 4, 9 divided by 3. Okay, and that's how we structure it right there, okay, in order to do long division. Now remember, to do long division, we're working with our 3 and we're trying to see how many times does 3 go into that number, okay? So our very first number was 4. So we said, how many times does 3 go into 4? 1 times. We take that number, we multiply it by 3. So 1 times 3, we put it down just beneath the 4. Then we do subtraction. So we say 4 minus 3. It gives us a remainder of 1, okay? Now we try and say how many times does 3 go into that remainder? Obviously, at the time, we just had 1, so 3 cannot go into 1. However, what we then do is we bring down the following number, which is in this case is the 6. When we bring it down, it becomes 16. Then we ask ourselves the question, how many times does 3 go into 16? The answer to that is 5. 5 times 3 is 15. When we do the subtraction, we get 1 again. Of course, 3 cannot go into 1. We bring down our 4. Then it becomes 14. How many times does 3 go into 14? The answer to that is 4, because 4 times 3 is 12. Okay. Then we do the subtraction, we get 2. Again, 3 cannot go into 2, so we have to bring down the 9. It becomes 29. How many times does 3 go into 29? That answer would be 9 times. 9 times 3 is 27, with a remainder of 2. Okay, we don't have any numbers to bring down anymore, so we add that as a remainder. Okay, so just revision of long division from last week. One second, I apologize. Okay, let's go through some short division. Okay, we're going to go through that today. Okay, let's go through some short division, okay? So I'm going to say how many times. Remember, this here is going to be 2975 divided by 4. So how many times can 4 go into 2975? So we do the same method as long division. It's just that we're not going to keep carrying the numbers down. Okay. So in this case, how many times can 4 go into 2? 4 cannot go into 2. And when you have the first number, okay, that our number cannot go into, we just place a dot, because 4 cannot go into 2. Thereafter, we work with the next two, with the 2 numbers. So we work with 2 and 9. Okay. I'm not sure if we will cover integers in this section, but we'll try. Okay. So now we're no longer working with 2, we're working with 29 as a whole. So how many times can 4 go into 29? The answer to that is 7, I believe. Okay. So that's 7. 7 times 4 is 28. Okay, so between 28 and 29, there's a remainder of 1. So what we then do is we place our 1 there next to our next number, which is 7. Okay, now in this case, right, we're going to say how many times does 4 go into 17? Okay, we treat that as a double-digit number. So how many times can 4 go into 17? The answer to that is 4 times. Remember, 4 times 4 is 16. So the difference between 16 and 17 is 1. Okay, so that's the remainder. Basically, you're going to carry your remainder to the next number, okay, and use it as a tens number. Okay, in this case, we have 4. How many times is 4 going to 15? 4 goes into 15 3 times, remainder 3. So the answer to 2,975 divided by 4 is 743 with a remainder of 3. Let's do another example. So here in this case, we have 7 and we have 9821. So this is 9821 divided by 7. So how many times can 7 go into 9? That's 1 time, remainder 2. Okay, so now we have 28. How many times can 7 go into 28? The answer to that is 4 with no remainder. Okay, 7 can go into 28 4 times with no remainder. Okay, now because there's no remainder, we have to ask ourselves how many times can 7 go into 2? Now 7 cannot go into 2. So just like how you put a dot when the number was at the start, in this case you will put a dot, but actually the dot represents a 0. So in this case it's 0. 7 cannot go into 21. Sorry, 7 cannot go into 2. Then we ask ourselves, how many times does 7 go into 21? And the answer to that is 3 times. So the final answer to 9821 divided by 7 is 1403. Okay, short division. Okay, let's move on to some rounding off. Okay, so let's just do revision of rounding off before we do this little rounding off and compensating. So when we talk about rounding off, okay, remember these key rules. 0 to 4 stays the same. 5 to 9, you round 1 up. Okay, so let's look at this example where we have 1527. Let's just down. Where we have 1527. Okay, now 1527, they want us to round off to the nearest 10. Okay, so when we're rounding off to the nearest 10, remember we have in this, okay, units, tens, hundreds, thousands, 10,000s. Okay, so they want us to round off to the nearest 10, which is this number here. Whenever we're rounding off, whether it's nearest 10, nearest 100, or nearest 1,000, we need to look at the number that follows the 10, which in this case is the unit. And that is going to decide whether we round up or we round down, or we keep it the same, essentially. In this case, the unit is 1. So it's from 0 to 4, so it stays the same. Okay, so in that case, the closest 10 to 21 is actually 20. So we're going to round this guy off to 15720. Because remember, the units is 1, which is from 0 to 4, so it remains the same. And the closest 10 to 21 is 20 and not 30. So that's why we write 20. Let's talk about nearest 100. So here's our 100 column here, which means we're going to be looking at this guy, which is our tens column. So in the tens column, is it from 0 to 4? Is it from 5 to 9? In this case, it is from 0 to 4. So we're going to keep it the same as well. So the closest hundredth to 721 is 700 and not 800. So it's going to become 15700. Okay, then we talk about nearest 1,000. Now in that case, here's 1,000, hundreds, tens, unit. Whenever we're rounding off to the 1,000, we need to look at the number that follows, which in this case is the 100. Is the number from 0 to 4 or from 5 to 9? In this case, it is from 5 to 9. The number is 7, right? So since the number is 7, we need to round 1 up, okay? So rounding 1 up means that we will change the 1,000 number from 5 to 6. So it becomes 16000. So basically, we are saying the closest 1,000 to 5,721 is actually 6,000 and not 5,000. Okay, so that's just the division of rounding off. We need to know how to round off, of course, right? So let's look at this little section, rounding and compensating. The word compensate means to do things that will remove damage. Okay, so this says approximate the answer for 386 plus 3435 by rounding both numbers off to the nearest 100 and adding the rounded numbers. Okay, so let's round both of these firstly to the nearest 100th. In this case, I have 100 tens units, 1,000, 100 tens units. Okay, so what I need to do is I need to look at the tens and I need to look at the tens in order to round it off to the nearest 100. So 300 is going to round up to 400 and 3,435 is going to round down or stay the same as 3,400. Okay, because 3 is between 0 and 4. When I add this up, I get 3,800. Okay, B says because you rounded 386 to 400, you introduce an error of 14 in your approximate answer. What error did you introduce rounding 3435 down to 3,400? So basically what they are talking about is because we are rounding, okay, it's not the exact value of the number. So this calculation 386 plus 3435 is actually not 3,800. 3,800 was just an estimation that we used because we rounded these numbers off. It is much easier to do the calculation. Okay, but now they are telling us, okay, so there's an error. For example, when we rounded 386 to 400, when they say there's an error, it just means the amount that it's different by. Okay, so in this case, 386 plus 14, okay, would give me 400. So in that case, we would state that there's an error of 14 between those numbers. The true number is 368. Our rounded off number is 400. So we call that an error of 14. So they're asking, what error did you introduce by rounding 3435 down to 3,400? And that error would simply just be 35. Okay, so there's an error of 35 because 35, the actual number is 35 more than our rounded number. What is the combined total error introduced by rounding off? Okay, we can just leave that out. Use your knowledge of total error to correct your approximate answer so that you have the correct answer. Okay, so basically what we can do in this specific case is we take our rounded off answer because remember 400 was rounded off, 3,400 was rounded off as well. So when we added them, we got basically, we can call this the rounded answer. Okay, it's not the exact answer, it was the approximate answer. Okay, so we know that the answer is definitely close to this answer. Okay, but now they want us to utilize this method of compensating in order to get the exact value. Okay, so in that case, we take our rounded answer, okay, and we make the changes necessary to it. So whatever our error was, okay, we basically make that change to 3,800. So in this case, right, we removed 35. Okay, we removed 35. So therefore, to our rounded answer, we have to add it because in the rounded answer, there is 35 missing. Okay, and remember, there's an error of 14 as well. But remember, with 14, we added that 14 to get to 400. So there's 14 more than we should have. That answer, okay, is 14 more than it should be because of our rounding. Okay, because we added 14 and we got 400, therefore this answer is 14 more than it should be, okay? And it is also 35 less than it should be. In that case, what we have to say is 3,800, we have to add 35 because remember it was 35 less. Now we are compensating for that error and we are adding it back to the number because initially we took it out, so now we're adding it back. So we are going to say 3,800 plus 35, but minus 14. Plus 35, but minus 14. Okay, so in that case, I can actually do this calculation first, even if I'd like. 35 minus 14 is 25 minus 4, which is 21. And therefore, I can say 3,800 plus 21, and that gives me an answer of 3,821. Okay, so it's just rounding off and compensating, basically compensating for the errors. In the case where you have more than you should have, you need to subtract from the rounded answer. Okay, in the case where you have less than you should have, you need to add to the rounded answer. Okay, and that's what we did in this case. We added the 35 that we took out by rounding off, and we subtracted the 14 that we added by rounding off. And now we have the exact answer of 386 plus 3435. Okay, here are some other examples that you guys can try on your own. Let's move on. Okay, let's talk about product of prime factors. Okay, so firstly, we're going to talk about a prime number itself. A prime number has only two factors, one and itself. Okay, so yes, okay, if we talk about a factor firstly, remember that a factor is a number that can go exactly into another number, okay, with no remainder. So let's talk about the number 24. Firstly, number 24, I know that 1 can go in an exact amount of times. It can go in 24 times. I know that 2 can go into 24 an exact amount of times. It can actually go 12 times. I know that 3 can go into 24 an exact amount of times. It can go 8 times with no remainder. I know that 4 can actually go into it an exact amount of times, right? It goes 6 times. Then I know there's 6. I know there's 8. I know there's 12. And I know there's 24. Okay, so quite a bit of numbers, 7 numbers, 8 numbers actually in total that can go into 24. And these are the factors of 24. Okay, why are they the factors of 24? Because they can go into 24 an exact amount of time with no remainder. Okay, so we call them factors of 24. So a prime number, okay, is a specific number where it only has two factors. It has only two factors, one in itself. So for example, if we look at 24, we cannot call 24 a prime number. Why? Because 24 has 8 factors. It's not 2, right? A prime number only has 2. Let's look at the examples of prime numbers. These are the first few. You should know at least the first 5, 6, 7 or so. Okay, at least like the first column, the first row, sorry, right? So let's look at 2. There's only 2 numbers that can go into 2, 2 and 1. 3, 3 and 1. 5, 5 and 1. 7, 7 and 1. 1 and 7, 1 in itself. For all of these numbers, only 1 and itself can go exactly into them. That's why we call them prime numbers. Example 17 is a prime since it only has 2 factors, 1 and 17. Cool. Okay, then we have composite numbers. Okay, now composite numbers, a composite number has more than 2 factors. So basically every number that's not a prime number is a composite number. So 24 is an example of a composite number. Why? Because it has more than 2 factors. Okay, so let us talk about writing values as a product of their prime factor. So now we know what the factor is. We know what the prime factor is. Okay, so now we're going to talk about writing products as writing numbers as a product of their prime factors by using what we call the ladder method. So basically, we're going to take the number, which in this case is 24, and we're going to create 2 columns like this. Okay, now on the left-hand side, okay, we have the number first, but on the right-hand side, we're actually going to divide this number only by prime numbers. Only by prime numbers. Okay, we're not allowed to. We're only going to divide it by prime numbers until we get to 1. So let's look at 24, right? So look, when you're dividing it by a prime number, it doesn't have to be the highest prime number, okay? It can be any prime number, to be honest. You're going to cover it. You're going to cover all prime numbers nevertheless, right? So let's think of a prime number that can go into 24. So I can see 2, 3. Okay, that's it for now, 2 and 3. All right, so both would work. In this case, I'm going to choose 2. Okay, when I divide, so now what I need to do is I need to remember we are writing it as a product of its prime factors. So I'm going to divide by prime numbers only. I'm going to divide this side, this 24 by 2 and put the number below 24. So when I divide 24 by 2, I get 12. Put our prime numbers in red. I get 12, right? Now I need to take this 12 and I need to divide it by another prime number, and 2 can go into it as well. When I divide 12 by 2, I get 6, which I need to divide 6 by a prime number. I can use 2 again. When I say 6 divided by 2, I get 3. Now I need to divide 3 by a prime number itself, right? 3 itself is a prime number, so you can divide it by itself, which is a prime number. And when you divide 3 by 3, you get 1. So now we are done. As soon as we reach 1, then we are complete. So now in this case, we have 24 written as a product of its prime factors, right? So 24 divided by 2, that gives us 12. 12 divided by 2, that gives us 6. 6 divided by 2, that gives us 3. 3 divided by 3, we get 1. So we are constantly dividing by prime numbers. So let's do this last example, or we can do both, it's fine. So 45, we are going to write as a product of its prime factors. Okay, so 45, we need to think of a prime number that can go into 45. The first one that comes to head is actually 5. 3 as well could work, but I'm just going to divide by 5. Again, it doesn't matter which one you start with. You're going to get through all of them nevertheless, right? 1 second. Okay, so when I divide 45 by 5, I'm going to get 9. Now I need to think of a prime number that I can divide 9 by, and that would be 3. When I divide 9 by 3, I actually get 3. Then I can divide 3 by itself to get 1. So now I'm done. I've written 45 as a product of its prime factors. Let's do 500. So even the bigger numbers are not that scary, right? Because firstly, as long as it's even, you can always divide it by 2. So that's exactly what I'm going to do. 500 divided by 2, that's 250. 250 is still an even number, so I can divide it by a prime number, which in this case is 2. So I divide it by 2. When I divide this by 2, I get 125. Okay, now 125 is, of course, an odd number, so I cannot divide this by 2. However, I can divide it by 5 because it ends in 5, so therefore it will be divisible by 5. So when I divide this guy by 5, I get 25, I believe. Okay, 25, I need to divide by a prime number. Another prime number that can go into 25, again, is 5. When I divide 25 by 5, I actually get 5. And finally, I can divide 5 by itself, because it itself is a prime number, until I get 1. So there are these 3 numbers written as products of their prime factors. If you have any questions, please leave them in the chat or in the Q&A, or for those on YouTube, in the YouTube comment, in the YouTube chat. Okay, so now what I can do, okay, is I can write it in exponential form. Do we go through it? It's fine, we'll go through it here. So exponential form is simple, okay? So what I'm going to do is I'm going to group my numbers that are the same. So remember, it's a product of prime factors. Product is a multiplication. Product is the answer to a multiplication. In this case, I'm actually saying 2 times 2 times 2 times 3. Remember, 2 times 2 is 4, times another 2 is 8, times 3, 8 times 3, that's 24. So I can see that when I multiply the prime factors, I get 24. So that's why it's written as a product of its prime factors. Now, in this case, I can group my the multiplications. In this case, I have 3 2s, so I can say 2 to the power of 3 times 3. In this case, I can say 5 times 3 to the power of 2, because I have 2 3s, and here I have 3 2s. In this case, I can say 2 to the power of 2 times 5 to the power of 3. Okay, so that's just exponential form. You'll see why it's important later. Actually, right now, when we do HCF and LCM. So HCF and LCM, highest common factor and lowest common multiple. So the first we're going to start off with is highest common factor. We have steps written out. So the first step is to prime factorization of each number. So you need to write out the prime factorization of each number, which we just learned, right? That's why we learned it, so that we can utilize it to calculate the highest common factor between 2 or 3 numbers, okay? So, yes, we first need to do the prime factorization of each number, obviously using ladder method. Then it says identify the common factors, multiply the common factors only on one side. Okay, so that's going to make sense once we do prime factors. So let's do it for 36 and 68. So prime factorization of each number is what they want. So I'm going to write 36 as a product of its prime factors. So 36, which prime factor can I divide it by? I can try 2 because it's an even number. When I divide 36 by 2, I get 18. I need to divide 18 by a prime number. I can choose 2 again. When I divide 18 by 2, I get 9. 9, I need to divide by a prime number, and that would be 3. Okay, remember our prime numbers are these values here. Factors that can, they only have 2 factors. Sorry, numbers that only have 2 factors, 1 in itself. And these are the first few examples, 2, 3, 5, 7, 11. And like for prime factorization, you'll mostly just use those, right? The smallest values. Okay, so now in this case, when I say 9 divided by 3, I get 3. And 3 I can divide by itself to get 1. Okay, let's do 68. Okay, 68 is an even number. I can divide it by 2. When I divide 68 by 2, I get 34. 34 is an even number. Again, lovely. So any even number, you can always divide it by 2, which is a prime number, right? I divide 34 by 2, and I get 17. Okay, now, of course, 17, right? 17, no prime number can go into it. That's because it is a prime number itself. So I can divide it by 17 to get 1. Okay, let's just copy these for LCM as well. Okay, so in this case, now that I have written the prime factorization of each number, I need to follow step 2, which says identify the common factors and multiply the common factors only on one side. Okay, so what does that mean? Common factor, we're talking about the prime factors. So if I have a 2, so when it's common, it means it needs to be on both sides, in both prime factorizations of both numbers. So in this case, I can see that I have a 2 there and I have a 2 there. Okay, so that's common. Okay, I have at least 1 2 common in both numbers. Then I look at my second 2, I have a corresponding 2 on the other side. Okay, so in that case, that's a second common factor. Let's talk about 3. I have 3 on the left, but there's no 3 on the right. So that is not a common factor. So I don't circle it, right? Let's look at the second 3. I have the second 3, but of course, there's no second 3 on the right hand side. So that's not a common factor. The same applies with 17. It's not common in both of them. Okay, so now in this case, I have identified the common factors. They say multiply the common factors only on one side. Only on one side means that we're only going to multiply these 2 common factors. Okay, so we identify them. Okay, you can literally just identify them in one of them. Okay, you don't have to highlight in both of them like I just did. Okay, so I've identified that 2 and 2 are basically my common factors. So now in that case, what I do to calculate my HCF is I multiply those common factors that I've just identified. So 2 times 2. Okay, 2 times 2, and of course the 8, that gives me 4. So now I have solved for the HCF. The HCF in this case is 4. And you got it from 2 times 2. Okay, let's do it now for 3 numbers. Highest common factor for 3 numbers. So I'm going to try and speed through this ladder method prime factorization thing so we can go fast. 2 and 12. Okay, I'm not going to even write it in 2 colors. 2 and 12, 2 and 6, 2 and 3, 3 and 1. If I make any mistakes, please stop me. 2 and 14, 2 and 7, 7 and 1. So what, 42? 2 and 21, 7 and 3, 3 and 1. Okay, that should be it. Let's do highest common factor. Highest common factor says we need to identify. So we've done step 1, which is to write out the prime factorization of each number. Step 2 is to identify the common factors. And then step 3 is obviously to multiply the common factors only on one side. In this case, because it's 3 numbers, it actually needs to be common in all 3. So the first 2, I can see that there's at least a 1 2 there, 1 2 there, and 1 2 there. So I know that this guy is common. This guy is common in all three sets of prime factorizations. Let's look at the second two, right? So second two is in the first one. In the second one, okay, maybe we can actually let's just copy this for LCM before we continue. Okay, so yes, we've identified this is common. Okay, common. Let's look at the second two. Now we have a 2 there. We have a 2 there. Okay, so it's common in the first and second, but not the third. There's no 2 here. Okay, so since it's not common in all three, we do not identify it as a common factor. Okay, there's another 2. Of course, it's not going to be common. Let's look at the 3. The 3 is only common in the first and the third, not the second. So therefore, it is not regarded as common. So in that case, we only have one factor that is common, and that is 2. So basically, our HCF is just 2. Okay, we should be able to go through rate and ratio. Okay, so therefore the HCF is 2. Right. Now let us talk about lowest common multiple. So the lowest common multiple has 3 steps. Okay, so we've done HCF for 2 numbers. Yes, high. So yes, do we have questions? Again, if you have questions, please, if you have questions, please leave them in the chat and the Q&A. Okay. So the person who asked if I can repeat rounding, just for the sake of time, okay, is it possible that after the lesson that you could re-watch the video and try and utilize the same explanation? Okay, just confirm with me if that's okay. If that's not okay, I can try and go through it again. Yes, we are going to go through ratios next. Okay, so lowest common multiple. So what's lowest common multiple, right? Step 1 is to do prime factorization of each number. Step 2 is to write each factor in exponent notation, which you've learned. And then step 3 is to multiply each factor with its highest power. So let's make that make sense in practical essence. So we've completed step 1, which is to write it as a common, to write the prime factorization of each number. Step 2 says that we need to write each factor in exponent notation. So that's what we're going to do. I'm going to say 2 squared times 3 squared. 2 squared times 3 squared. And in this case, I'm going to say 2 times 17, because it's 2 to the power of 1 times 17 to the power of 1. Okay, then it says multiply each factor with its highest power. So basically what that means, okay, is we're going to have factors such as 2, 3, or prime numbers, right? So for example, I have 2 here and I have 2 there. I have 3, okay, I only have 1 3 and I only have 1 17. We need to multiply each different factor with its highest power. So in this case, 2's highest power is 2. Okay, this one is 2 to the power of 1. So its highest power is not 1, of course, it's 2. So I'm going to take 2 to the power of 2. Then I need to multiply it by 3's highest power, and it's 3 to the power of 2. So I'm going to say multiplied by 3 to the power of 2. And finally, I'm going to multiply it by 17's highest power, and 17's highest power is 1. So, sorry. Oh, yeah, that's correct. 17's highest power is 1. So it's just basically 17 to the power of 1, or just 17. Okay, when I do this calculation, 2 squared, okay, times 3 squared times 17, I get an answer of 612. And that is actually my lowest common multiple. Okay, let's just discuss what a multiple means quickly, just to confirm. A multiple, okay, is basically your multiplications timetable. So when you take a number, okay, and you multiply it by natural numbers, so times 1, times 2, times 3, times 4, times 5, times 6. So any number, I could take 7, and I could say 7 times 1, 7 times 2, 7 times 3, 7 times 4. And all those values would be 7's multiples, okay, when you just multiply a number by then all the natural numbers, okay? Let's talk about 3 numbers. So let's look at this case. For lowest common multiples, step 1 has been completed. We have written 24, 28, and 42. We've written the prime factorization of each number. Step 2 is to write out the exponent notation for each one. So 2 cubed, in this case, 2 to the power of 3, because I have 3 2's, multiplied by 3 to the power of 1. So for each number, that's what I'm going to do. 2 to the power of 2 times 7, and this is 2 times 7 times 3. Step 3 tells us multiply each factor with its highest power. So in this case, I have actually 3 different factors, 2, 3, 7. 2, 3, and 7. Okay, I have 3 different factors, 2, 3, and 7. Okay, so I need to multiply the highest exponents. The highest exponent for 2 is actually 2 to the 3. The highest exponent for 3 is 3 to the 1. And the highest exponent for 7 is 7. So now I multiply this to get my LCM. The LCM is 2 cubed times 3 times 7. I get an answer of 168 as the lowest common multiple. When we are doing exponents of 1, so and negative. I'm confused to your question. Are you asking when are we going to be doing exponents? Okay, exponents is if you must write. Okay, are you asking whether you should write notes? Okay, remember guys that these sessions are recorded. Okay, so you will have access to the entire session, the entire recording video on YouTube after the lesson is completed, and you will have access to notes. There's a link to a Google Drive in the chat, in the description of the group that you're in. You will have access to a Google Drive where all the notes that we do will be available there. Okay, so you can choose if you'd like to write, or if you want to write or not write, that's up to you. However, just know that you are going to get the notes. Are we going to do finance? I'll try my best to get to it, but it does not look like we're going to be able to get to it. I do have a document for it, but we have to still cover rate and ratio. Okay, again, when are we going to do exponents? Are you asking exponents as a whole, or are you asking specific with regards to this? Okay, let's look at rate and ratio. So the first thing we're going to discuss is ratio. Okay, a ratio is a way of comparing two quantities that are the same. Some real life examples are, okay, whatever. Comparing and simplifying ratios ensure all units are the same, or that all fractions have lowest common denominator. Divide each part by the ratio of the largest number. Okay, cool. Let's just go through it, right? So basically, a ratio is a way of comparing two quantities that are the same. So when we are given the task to simplify ratios, okay, the first step is we need to ensure that they are in the same units, okay? You cannot form a ratio between two values that do not contain the same units, okay? So in this case, for example, we have 2 Rand 20 and 60 cents. Those are two different units, okay? So we cannot compare rands and cents. We need to keep them on as the same units, okay? So I've written a few common, I've put a few common conversion table here, which you guys can go through. Right? Some are general knowledge, some are here. Okay, you need to understand them. Okay, so let's go through this first example. Okay, where I have 2 Rand 20 and I have 60 cents. Again, I cannot compare them because they are in different units. So I need to convert them to the same unit. So I'm going to convert them to cents. Let's convert them to cents. Okay, so I need to take 2 Rand 20 and convert it to cents. Remember, for each rand, we have 100 cents. For each rand, we have 100 cents. So when we're going from rand to cents, we need to multiply. When we're going from cents to rands, we need to divide. Okay, because there are more cents in a rand. Okay, so we are going from rand to cents, so we need to multiply. Multiply by what? This conversion. 1 Rand is 100 cents, so we need to multiply by 100. So I'm going to take 2 Rand 20 multiplied by 100, and I actually get an answer of 220 cents. Now I can compare this to 60 cents because they're in the same unit. Okay. Now in this case, remember our objective is actually to simplify the ratio. Okay, our objective is to simplify the ratio. So you don't have to go directly to your final answer. Okay, what you can do is take it step by step. So you need to divide them both by the same number. Okay, obviously provided that they're both divisible by that number. So in this case, I'm going to divide them both by 10 at first. Yeah, I'm going to divide them by 10. So when I divide these by 10, remember dividing by 10, the single zero disappears. So I'm left with 22:6. This is not the simplest ratio. So you did the previous question wrong, because you divide 2 and 7, which is wrong. You can't divide a small number first, and then a big number, and then a small number again. Okay, I'm confused as to which example you are actually talking about. Are you talking about long division? Okay, if you are talking about long division, just confirm with me, then we can go through it at the end. Okay, so we are simplifying ratios. So yes, I have 22:6. Now I can see if I can divide this by another number, both of them by another number, and I can, and that's 2. When I divide them both by 2, I'm left with 11:3. And now in that case, okay, I am left with the most simplified version of this ratio. Okay, alternatively, if your teacher is not too strict on using your steps in your calculator, you could put, remember, ratios could be expressed as, let's see something. Ratios could be expressed as fractions. So 220/60. If you put that in your calculator, you're going to get 11/3, and therefore your ratio is 11:3. So when we talk about ratios, it's basically stating the relationship between the two. So in this case, let's just say this is rands or cents. In this case, we're talking about. So let's just say this is person 1, that's 3, and person 2, that is 11. It's saying that for every 3 cents that person 1 has, person 2 has 11 cents. So if person 3 has 3 cents, then person 2 has, sorry, did I say person 3? There's no 3 people, there's 2. Okay, so if person 1 has 3 cents, then person 2 has 11 cents. If person 1 has 6 cents, remember the ratio remains the same. So for every 3, this guy is going to have 11. In 6, we find 2 3s, so therefore this will be 22. Okay, so if this guy has 6 cents, this one will have 22 cents following that ratio. Okay, let's look at this example where we have 5.2 liters and 600 moles, right? Okay, please, the person who asked that question, please clarify what you're asking about. The HCF 42. Yes, the HCF 42. Are you talking about this one? What about that HCF? Okay, please consider doing integers in the next lesson. Okay, so it's rate and ratio, then finance, then yes, we will be doing integers. So if we can cover as much as possible with this, and then do finance, and then we'll get to integers. Okay, so let's do this. Let us convert this guy to milliliters. So let's look at the conversion. So for every 1 liter, we have 1,000 milliliters. To go from 1 liter to milliliters, we have to multiply. To go from milliliters to liters, we actually have to divide. So in this case, we are going to go from liters to milliliters. So we need to multiply by 1,000. So multiply by 1,000. When we multiply by 1,000, we get 5,200 milliliters is to 600 milliliters. Okay, so yes, now we have it in milliliters. We can now simplify the ratio. This ratio is now, we can simplify it because it's in the same unit. Okay, we need to compare 2 quantities that are same. So in this case, I'm going to, I don't have to divide it. I don't have to simplify it in one step to its simplest form. Can you repeat it again? Could you please tell me what should I repeat again? Are you talking about this here? Okay. If you're talking about the first example, hopefully I'm going through the second example and it will make more sense. But if you're talking about something different, please let me know. Okay, so I'm going to divide both of these by 100. And I divide them both by 100, the zeros disappear. So I'm going to get 52:6. Okay, both are still even numbers and both can still be divided by 2. So therefore, it's not the simplest ratio. So I can say divide them both by 2. I will get 26:3. So, and I think that that is the simplest ratio, 26:3. Okay, so the first example, remember we had 2 Rand 20 and we had 60 cents. So two different units. Initially, we could not simplify this ratio because they are not in the same units. So what we did was we multiplied, we changed the Rand value to cents so that now they are both in cents. Okay, alternatively, what you could also do was change the cents to rands and then compare it. Okay, but then we'd have decimals. It wouldn't be so nice to work with. So then we finally got 220 cents is 60 cents. And now we need to simplify it. So we need to actually just divide both by the same value to continually simplify it. Okay, so then I divided by 10 first, then I could divide it by 2 again until I eventually got my simplest ratio, which is 11:3. Okay, you guys can do this one by yourself. Let's talk about increasing or decreasing a given ratio. So the first thing states that when increasing in a given ratio, the numerator needs to be bigger than the denominator. When increasing in a given ratio, the numerator needs to be bigger than the denominator. So basically, you are always going to multiply by the ratio. That's one thing we need to know. We need to multiply by the ratio. Okay, so we'll see what that means. The first one, it says increase 100 in the ratio 5:4. So, increase 100 in the ratio 5:4. So we are going to multiply by the ratio, but we have certain steps. It says when increasing in a given ratio, the numerator needs to be bigger than the denominator. So we multiply 100 by a fraction, which remember, fractions ratio is very similar, okay? However, because we are increasing, the numerator needs to be bigger than the denominator, so 5/4. So we multiply 100 by 5/4. Where did we get 5? Where did we get 4? That is the ratio, 5:4. So I'm going to create a fraction with the ratio, and when I'm increasing, I will have a numerator bigger than the denominator. In this case, when I do the calculation, 100 multiplied by 5/4, I get 125. In this case, it's rands because we are working in rands. Okay, so 125 rand. That is how I increased 100 in the ratio 5:4. Let's talk about decreasing a given ratio. When decreasing in a given ratio, the numerator needs to be smaller than the denominator. So remember, keyword here, decreasing. So basically, I need to put my bigger number as the denominator in this case. Here, I put my bigger number. When I'm increasing in ratio, I put the bigger number as the numerator. When I'm decreasing in ratio, I put the bigger number as the denominator. So that's exactly what I'm going to do. So I'm going to say 240 multiplied by the ratio as a fraction, but I'm going to put the bigger number at the bottom because I am decreasing in that specific given ratio. So I'm going to say 240 times 3/8. And that is going to be 90, in this case, milliliters. Okay, no problem. I'll repeat the first example. How did Sir multiply 100 by 5/4? Okay, so tell me just in the chat, type quickly if you guys are allowed to use your calculators. I just want to see who is allowed and who isn't allowed. Okay, I see a lot of yeses and a few no's. Okay, so for those who aren't allowed, I'm very sorry. I'll go through how I did this calculation in a bit. For those who are allowed, very lucky. Okay, so I just want to do two things quickly. I just want to, firstly, I'm going to just go back to rounding off decimals quickly because it's easy and I'm going to go through it. The lesson's going to go a little bit over time. I'm going to do two things. Okay, so obviously time is up. So we cannot continue with ratio and sharing. For the person who's writing the test in the week, I'm really sorry we couldn't cover all, but what you're going to have access to this document, right? So I would recommend I'm going to send this document. I would recommend going through the ratio and sharing section. There are some explanations. Maybe I will do one example and just leave it there just for you specifically, and then you can go through it yourself, right? So it ends there. We'll continue ratio and sharing next week, and then finance and then integers. For now, before we end the seminar, I'm just going to be going through two more things. The first thing is how to do this without a calculator. And the second thing is rounding off to decimals. So we're going to start, okay, actually it's the other way around. I'm going to do the decimal thing first. So when we talk about decimals, okay, so just say we have 7,2361. We have 7,2361. If the question says 2 decimal places, 2 decimal places. If the question says 3 decimal places, if the question says, let's just do 4 decimal places, right? Okay, so it is essentially the same thing. So if I'm going to round off to 2 decimal places, all that means is that in my number, right? Remember, this is before the decimal. Decimal values are after our digit, after our comma, basically. So 2 decimal places means after the comma, I want 2 numbers. After the comma, I want 2 numbers. So if I want 2 numbers, I need to look at the third number in order to round off the first 2 numbers. Okay, so 2 decimal places means 2 decimal places after the comma. That's all I want. I don't want the rest. I want these to be gone. So in that case, I need to look at the 6th. Okay, and remember, if it's between 0 and 4, you keep it the same. If it's from 5 to 9, you round 1 up. So in this case, 2 decimal places, this guy is going to round off to 7,24. Okay, so I just look at the next number and I round accordingly. So let's talk about 3 decimal places. When you round off to 3 decimal places, I need to have 3 numbers after the comma. So I need to have 1, 2, 3 numbers after the comma. So I'm going to look at the 4th number. And if it's between 0 and 4, I keep it the same. If it's between 5 and 9, I round 1 up. In this case, it is between, the 4th number is 1. So it's between 0 and 4. So I keep it the same. So this answer is going to be 7,236. It remains the same. Let's talk about 4 decimal places. If I need to round off to 4 decimal places, I need to have 4 numbers after the digit, after the comma, sorry, 4 digits after the comma. And I look at the 5th digit to round off. In this case, the 5th digit is 9. So I'm going to round that number up. So this is going to be 7,2362. Obviously, 1 rounded up is 2. Okay, so there we go. Decimals. I also send the answers on the worksheet to check if we are correct. Yes, I shall do that for all the questions that we need to do. Let's look at this calculation. Let's talk about 100 times 5/4. Actually, I think we will be doing more of these after integers. Okay, it's basically a multiplication of fractions. Okay, let's try and get this quickly so that we can end. Okay, for those who didn't clarify the questions, I'm sorry, I could not get to your questions. Okay. Yeah, just obviously we're doing a lot of things, a lot of questions. So when you ask your questions, try to be specific so that I know exactly what you're talking about. Okay, so let's look at 100 times 5/4. It is multiplication of fractions. So I need to, because I have one fraction, I need to turn 100 into a fraction as well. Anything as a fraction, if it's not a fraction, I can put over 1 to create a fraction. Okay, again, we'll be doing more of this after integers. Okay, so 100. So how do we multiply fractions? You need to remember that we multiply fractions in a straight line. Okay, so in essence, we're going to say 100 times 5 and 1 times 4. Okay, but before we do that, we can actually simplify anything that's in the numerator and anything that's in the denominator. If we can divide it by the same value, we can use that to simplify. So for example, I can simplify 5 and 1. Okay, in that case, it's already in its simplest form. I can try and simplify 5 and 4. It's already in its simplest form, right? There's no number that can go into 5 and 4 an exact amount of times. However, let's look at, okay, so it doesn't matter whether it's in a numerator of 1 and in the denominator of another. As long as 1 is in the numerator and 1 is in a denominator, you can try and simplify those values. So let's look at 104. I can divide both of those numbers by a single number. Okay, there's a common factor that goes into 4 and that goes into 100, and that value is actually 4. So when I divide 4 by 4, I get 1. When I divide 100 by 4, I get 25. Okay, now I've simplified things because I'm actually left with 25/1 times 5/1, which is essentially 25 times 5. And in that case, I get 125. Okay, so that's how you do it without a calculator. Again, we will be covering this when we do common fractions. So I'll explain what Sir is doing. So firstly, I was doing decimal rounding off. Okay. And then we've done, we just went through how to do this calculation without a calculator. Okay, so that is all we have time for. We'll have to end it there. Next week, we'll continue with ratio and sharing, finance, and let's try and get to integers, although I highly doubt it because finance is a lot. So let's see. Okay. Perfect. So Jazakallah khair. Thank you guys so much for joining. All the best. You will have access to these notes once more. I will see you guys next week, inshallah. Okay, thank you guys.